This group of problems deals all with quadratics and different ways to solve them. At the very beginning of the review we were solving by factoring. Now we're going to be solving by different methods. So number 30 asks you to use either the extraction of roots method, that's some books, other books call it the square root method. Either way, this is how one would do that. So here's our problem. We need to get rid of the square, so I'm going to square root both sides. That's why it's called the square root method. And so a square and a square root undo one another. They're inverse operations. So we just have 2x plus 5. Here you want to make sure you put the plus or minus, and you simplify 8, so we can take out a 2 and leave a 2. So that's the hard step, to remember the plus or minus and to simplify the square root. Now how do we solve for x? We're just going to subtract 5 from both sides, and then we're going to divide by 2. And you can leave your answer like that. You cannot reduce that at all. That's it. A lot of teachers might prefer you to write it in this format, but both are correct. Completing the square. How do we do this? Well, I ask my students to draw a blank there. I'm going to move this to the other side. I'm going to draw a blank there. You want to take half of this, add it to both sides, then rewrite this as a binomial squared. And now we're back to the problem like number 30. We use the square root method. So we have x plus 3 equals plus or minus. Can't simplify 6, so that just stays. And then I'm going to subtract 3 from both sides. And again, you could write your answer that's perfectly legal. You could also write it like that. Either way, those are the answers to the question. Okay. Solve by the quadratic formula. You first of all have to know what that is. And if you're headed toward college algebra, you have to know this. Make sure that fraction goes all the way across there. So we want to set it equal to 0. We want to identify a, b, and c. So a is 1, b is negative 4, c is positive 11. So I have x equals negative b, so that's going to make that positive, b squared minus 4 times a times c, all over 2 times a. So that's 16 minus 44. That is going to be negative 28, I believe. Still can't reduce. What I have to do is take care of this, 28. That's 2 times 7, and it's negative. So I can take out a 2 and an I and leave the 7. And yes, I put my I in front of the square root. A lot of teachers put it after the square root. Either way is okay. Now and only now can you reduce, since all three of those are divisible by 2. So dividing by 2, this is what I have left. 2 plus or minus 1i times the square root of 7 over 1. That's it. The last two problems deal with absolute value. Well, number 33 is an equation, 34 is an inequality. So let's go back to the equation. By definition, absolute value is the distance away from 0. So we have a positive distance, we could have a negative distance. So in order to remove the absolute value signs, you write two equations. Two equations. If you do not have two equations on the final exam, you will get no credit. Now you just solve those two equations. So the hard part about it is just knowing that you need two equations. One equal to the positive, one equals to the negative. That's it. So here I'm going to subtract 3 and divide by 4. Here I'm going to subtract 3 and divide by 4, and in this case I need to reduce the fraction. So my answers are 1 and -5/2. Again, if you do not have two equations, you get no credit. So be careful. It's easy. This last problem is solving an absolute value inequality, and it asks us to write our answer in interval notation and graph on a number line. This one's a little bit different than the previous problem because our absolute value is not isolated. So we need to isolate the absolute value, meaning I need to add 2 to both sides. And so I have 3x minus 1 is less than or equal to 12. Now we've isolated it. Now I need to remove the absolute value. The way I teach it, if this is less than, then it's sandwiched between -12 and +12. Your teacher may approach it a little bit differently, but at the end we're going to get the same answer. So because of the less than and a distance from the number line, if you have something and it's less than 12, here's 12, so less than is closer to that, but 12 units on the other side would be -12 and less than would be in between. That's where that comes from. So here I'm going to add 1 to all three parts. I get -11 is less than or equal to 3x is less than or equal to 13. Then I'm going to divide all three parts by 3. I'm going to get -11/3 is less than or equal to x, less than or equal to 13/3. I'm now asked to put that on a number line. Can be pretty basic. They need to be filled in because of the equal to part, and then x is between. So all of those numbers. And then an interval notation would be bracket -11/3, comma, 13/3, bracket. And so solving an absolute value, whether it's an equation or inequality, you have to isolate the absolute value sign. That means this part right here before you do anything else.